Like I was born yesterday. All right, CCA prep day 2, quadratics. I think this is the one you got to lock in for. I believe that. Yeah? This is the big one because there's lots of details here. Even if you did great in all the quadratics chapters, you might want to look at this again because now it's not all in one chapter. It's not 3 different tests. It's all on one day. Yeah. This unit will be covered by graphs, factoring, applying quadratic models, and quadratic equation. Date of CCA. If you're watching this on a video in a different year, this might not be correct, but we've set this as Thursday, June 13th. Yes? Thursday, June 13th. Open book, 75 minutes only. I've already seen a copy of this thing. There's no reason not to be done in 75 minutes. It's not meant to be long. I hope you found that with trig. It was not meant to be long. The people who took longer just must have got themselves all turned around and backwards. Here I go. Expand and simplify. Well, I hope this part of the review you're like, yes, 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 yes. I remember this. We had a catchphrase for this. Do you remember the catchphrase for this? Foil. Because foil tells you multiply the first ones together. Multiply the outside ones together. Multiply the inside ones together. And then multiply the last ones together. Foil is really a grade 10 saying because in grade 11 and 12 sometimes there's more than 2 things in one of the brackets. But it's nice in grade 10. It's a nice word to help you. But that is not all. No, that is not all. What else do you have to do to these things? Simplify. Almost always, after FOIL, there's a simplification step where you can collect up like terms. Shh. Okay, is that okay? Here's a special case. This one messes people up all the time. They want to just square each of the individual terms, and it's not right. That's not the way it works. You can't just square 2 things that are added together and get the right answer. You have to put this into 2 separate brackets. X plus 12 times x plus 12. Anything else does not work. And then you do your FOIL deal. Some people don't actually call it FOIL. They just use these arrows, and the arrows tell them everything that's got to happen. Everybody, what did I do in class? I think I did a van example. Everybody in this van has to shake hands with everybody in that van. Yeah? I think that's the example I used in class. It was me in my van pulling up to see somebody else in their van. And then here. And then here. Are you pretty happy so far in the quadratic review? I hope so. I hope if you remember nothing else about quadratics, you remember that. This one's troublesome. And see, the review is very careful. It doesn't spend a lot of time on these things. It just goes, you remember these? What else could go wrong? Maybe with a squared like that. Or maybe there's a coefficient out front. Now, there's lots of ways to handle this. I encourage you to leave the coefficient out. I think that's the easiest way to handle it, but you don't have to. I could multiply that coefficient into the first bracket and then FOIL. That totally works. I suggest for most people, it works better to leave the -2 out front, do the FOIL, and then multiply by the -2. But one's not better than the other. That's just me saying, okay, here's what I think is a little bit better. So then I get x squared minus 5x plus 5x minus 25. And this one, laying the foundation for difference of squares, -5x, positive 5x, those things add up to nothing. So all I got left is this. And then I multiply the -2 in and get -2x squared plus 50. Now, if you did it a different way, and got the same answer, that is totally fine. If you distributed the -2 into the brackets and then did the whole FOIL thing, it'll still work, okay? Do you have any questions about those 3? I think that's as FOIL-y as we get. It's from beginning to end, starting with a medium one that's got coefficients on there, and then what could go wrong. I think that covers all of it. So if you were going to, I know we talked about not flipping during the culminating, but if you were going to flip back to one page, this is a pretty good page to flip to because it shows you all the things that could happen, I think. Yeah? More time there? We've got to get at least halfway today. Now, factor. We did a lot of factoring. And it came down to a set of questions we asked ourselves. We went first. Is there a common factor? Does this first one have a common factor? No, no common factor. Next, is it a trinomial? Does it have 3 terms? Yes, this one does. And then finally, the one we're not worried about, is there a coefficient out there that's not equal to 1? No, there's not. So this is, I think, many people's favorite type of factoring. This type right here. Simple trinomials. All you got to do is find 2 numbers that multiply to negative 14 and add to 5. Now it's just about perseverance. Playing around, whatever tricks you have to playing around to get it. Negative 2 and positive 7. And you use those like that. Now, if that all happened too fast for you, what you could do is write out all the things that do multiply to negative 14. So you make little notes up here and go, well, 1 and negative 14 clearly multiplies to negative 14, but doesn't add to give 5. Then you go 2 and negative 7. See, I call it a systematic approach. 1, 2, 3. I'm just going to go through all of them until I find it. 2 and negative 7 adds to negative 5. Oh, I'm on it now. It's got to be negative 2 and positive 7. And it's okay if you're doing those things. After all that's done, I'm bewildered why simple factoring isn't always correct. That is, after somebody does this stuff, how they could possibly get this one wrong and not know it. What am I talking about? Why is it you can always know if you got it right?
You just refactor it.
You can just FOIL that back out and double check that it works. Now I understand time's an issue. So after you factor, you go, okay, I got it. I think it's right. Then you go through the rest of the test, and then when you come back, you just do a little foiling and go, yep, that's right, yep, that's right. So the foiling checks all those things. So please use FOIL to check. In fact, I think on one of your tests, we actually force you to check. We go, oh no, now you check, to try to teach you the lesson that checking is easy.
Can 7 be in the first bracket?
Yeah, if someone wrote x plus 7 in the first bracket and x minus 2 in the second bracket, that's totally right as well. And I'll explain why. You learned this with your multiplication tables. 3 times 5 is 15. 5 times 3 is 15. Multiplication is very friendly like that. If you do it the other way around, it doesn't matter. So if these 2 brackets were the other way around, you get the same thing. That's the only simple trinomial on that in the factoring part of this. Now we go on to this kind. Back through the checklist. Does it have a common factor? No. Is it 3 terms? No. So if it's not 3 terms, what kind of factoring is it?
The square one.
Yes, the square one. It's difference of squares. You look at it and go, oh, are these things both something squared? That is there something that squares to give x, and is there something that squares to give 7? Yes. X squares to give x squared. It's almost too easy. It confuses you when I say it like that. But the other one is 7 squared. Whoa. Yum. Oh, okay, my touch screen is losing its mind here again. There. 7. Ooh, there's still another little. Jeez. Fun stuff today. 7. So then what do you do with that? Do you remember? What do you do with the x and the 7? Same, yeah, right. Now it's the same as this. I've got my numbers. It's 7 and negative 7. So I've got 2 brackets, x plus 7, x minus 7. What if you weren't sure? What would you do next? You just FOIL it out to make sure it works. Okay, so no excuses as you head off into grade 11 for not getting the factoring ones right, because you can always FOIL to check. Okay, lots of factoring coming in grade 11. Okay, next one. Does it have a common factor? No. Is it 3 terms? Yes. Complex trinomial. We learned several ways to do this. My brain tells me that decomposition was the most popular by the time that was all over. Yes? If you've got another method, that's great, but here comes decomp, okay? What did we do? What did we do? Who remembers the first sort of magical step? Decomp has sort of a magical first step. Sorry, this thing's misbehaving. Just give me a second to fix it up and giving you time to think. Well, I tried to buy myself some extra space and it didn't work. What do you like here? Yes. We called it AC. You don't need to call it AC, but she says, hey, multiply the 5 and 8 together. And that gives 40. So what?
You have to find two numbers that
Multiply
multiply to 40
to 40.
and then
Add to negative 14. So you might make your whole list there again and go, okay, what are the things that multiply to 40? 1 and 40? No, it's not 1 and 40. 2 and 20? No, it's not 2 and 20. 3 and I don't know. 3 doesn't work. 4 and 10. Oh, 4 and 10. Well, no, not exactly 4 and 10, is it? Negative 4, negative 10. Once you got the one that gets the wrong sign, you know you're really close. You just got to get the other one. So this is weird, right? 5x squared minus 4x minus 10x plus 8. Not that weird yet. If you think decomp is weird, that's not the weird part. Now the weird part. Common factor the first pair. Common factor the second pair. And if everything goes right, and I don't write it down wrong, the two brackets will be the same. And so your two pairs are the 5x minus 4 in the first bracket, and what's remaining when you pull those out. When I pull 5x minus 4 out of the first set, I get x. When I pull 5x minus 4 out of the second set, I get negative 2. What was the other option? If this now, just look at it and go, no, I don't decomp. Yeah, making the windows. And it's sort of a trial and error thing, is you just keep making the windows until it works out, okay? There's another one coming up here. So I'll try and do this one with a window over here, okay? Because this is solved by factoring. Now, if that was only good factoring review, now we have questions where we have to solve by factoring. It was like in a separate chapter, I think, which it didn't really have to be, because once you can factor, you can solve these equations by factoring. So here's the checklist again. Common factor? No. 3 terms? Yes. Simple trinomial? Yes. So I'm just looking for 2 things that multiply to negative 44, but add to negative 7. Here goes the whole list again. 1 and 44? No. 2 and 22? No. 3 doesn't work. Negative 11 and positive 4. But I'm sorry, if you know what you're looking for, it's just perseverance. It's just playing with your calculator until you find the 2 terms, 2 numbers that multiply to that 44, but add to the negative 7. But that's not all in these questions. Solved by factoring was different. It said, okay, if this bracket could be equal to 0, I get x minus 11 equals 0, or x plus 4 equals 0. I hope the rust is coming off that, because we were pretty good at this. This went pretty well once we got there. That x could be the 11, or x could be negative 4. Do you remember reversing the signs here? Whatever was in the brackets, we were looking for the opposite signs. And if you don't, that's fine. We threw a lot at you in a short period of time. That might have been the most intense 2 months of math that you've seen yet, was the quadratics chapters. It went slow, but it built up a lot of stuff. Like there was a lot in those chapters. But I paused for questions. Tell me now. Don't wait around till Thursday to ask what the heck is going on. Now's the time. I'm right here. I can tell you what the heck is going on.
Why is it positive 11 if you're subtracting 11?
We need a number now. Now that we've factored it right there, we need a number that if I make x equal to that number, that bracket becomes 0. So the number that I subtract 11 from to get 0 is positive 11. That's why it's the opposite sign, because we're trying to make that bracket equal to 0. And then in the second bracket, I want a number that when I add 4, I get 0, and that number's negative 4 that I add 4 to get 0. Good question. Other questions? Well, this is identical, except we're right back to a mini trinomial. Josh? He says it common factors. Yeah? It looks like it's going to be a mini trinomial, except it's not. It common factors. 84 divided by 3. So if for no other reason than it saves you work, always check for that common factor first. Is it still written on the board? I must tell you, I leave that on for my calculus people too. And in my other classroom, on the other side of where I'm teaching the advanced functions people, there's one of these, and it's a marker up there in the corner. Same thing, because it's true in all the courses. It's not a grade 10 thing. Every time there could be a common factor, check for it, because it makes your life so much easier here. You don't have to go through all the steps of crazy decomp here. You can just go 3, x plus 7, x minus 4, because those are the two numbers that multiply to negative 28. But add 2, 3, and then I get my two answers, x equals negative 7 or x equals 4. Now, I jumped there because that's what some of you are used to. By the end of the chapter, I think we were often jumping right to the answers here. I like these steps better, me personally, where you take each bracket out and go, let's solve it out, because it really shows what's happening. But I show this way as well, just in case that's what triggers your memory about what we were doing there and find the numbers that make the brackets equal to 0. Austin. The 3 can't be equal to 0. Only the bracket can be equal to 0. That is, there's no number I can sub in and turn this 3 into a 0. So it becomes not really part of the answer. I don't really need it. All it is a vertical stretch, actually, is what's happening, and so the zeros stay where they are. So I only care about the parts that I can put x's into, the ones I can vary. I can put a variable in there and change what those numbers are. Okay, you tell me what questions you have. Incidentally, now, if you're going back to do exam review, the ones that have FOIL and the ones that are solved by factoring, those are the ones you should look for first and go, oh, we reviewed those. I'm feeling a little better about those, or at least I have my review pages on them. Quadratic formula. When we first saw it, maybe scary. After we did it a bunch of times, hopefully not too bad. However, this particular question is not quite ready to be used. The quadratic formula cannot be used just yet. There is a small, well, there's actually 3 small problems. What do I have to do? Yeah, the quadratic formula solves equations in this form, where there's 0 on one side. That's its whole setup. So before we even start, we've got to bring that 3 over. And what a great study page this is going to be to bring into your culminating, because this is what I'll go carefully through quadratic formula. If you had to flip to something, this is a nice thing to flip through on quadratic formula, right? It says x equal, oh, I'm going to leave a little space here. Leave a little tiny space here, because I got to do something. Let me write down the quadratic formula. It says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But the question is, what's a, b, and c? Easy as 1, 2, 3. Well, what is a in this question? Yeah, the 8. It's the coefficient on x squared. That's where right from the beginning, I started calling it a. And everybody's like, why are you calling it a? And as the chapters went on, we got more used to the idea that a will be, we're just using that to represent that first coefficient. B is that second coefficient. And C is that constant. So those three numbers, A, B, and C, can be picked right off of the formula. Now I'm just subbing them in. So I get x equals negative 10. Negative 10. Yes, really? Negative 10? I noticed on your test sometimes people would just write positive 10. They're like, okay, I know what's happening there. But I write it here just so you can see where that's coming from. And then b squared, which is negative 10 squared minus 4 times 8 times negative 3. All over 2 times the a, which is 8. And what we talked about in class was handling that whole bracket, sorry, that whole underneath the square root part as 1, and just calculating that. In some classes, we called it the discriminant, and because it helped decide how many zeros we're going to get. That's not what I'm talking about right here necessarily. And so I typed that in, negative 10 squared minus 4 times 8 times negative 3. $196. Did anyone type it in? Is it 196? And 2 times 8 is 16. And square root of 196, what's that? 14. It didn't have to be nice, friends. I hope you saw another quadratic formula questions, and we will see before this review is over. It doesn't have to come out to a nice number like that. This one happened to, and that's okay, that's fine. So then there's two answers. Here's the plus minus thing. X equals 10 plus 14 over 16, or x equals 10 minus 14 over 16. There's the two answers. And we shouldn't be surprised by two answers. We're talking about a parabola, so a parabola can have a 0 two different times. So I get 24 over 16, or negative 4 over 16. Yes, I know about the decimals. But decimals is easy, so let's prepare for fractions. Yeah? If they want the answer in fractions here, what does this come out to be? What does 24 over 16 reduce to? 3 over 2. And what about negative 4 over 16? Negative 1 over 4. Yes, there's places for decimals. I might have seemed anti-decimal at times. I'm not. But I know decimals are easy. I can just punch in my calculator and get them. So let's prepare for the fractions, just in case that comes up. That's my strategy. Questions about the quadratic formula? I guess if it was me, this sheet here, if I was going to flip to something, this really covers a lot of the high points. Are you going to get 100% in the culminating just having this sheet? No, but you're going to solve a lot of your problems. You're going to have a lot of stuff already taken care of in the culminating as long as you have this available, right? And really helps you to get ready for the exam too, because you know what you need. Ellie? Yes. That's a great question to ask after CCA day 3. It's like, okay, I was okay, good CCAs. Now tell me all about the exam formulas. Now, I think on the exam review, if you start the exam review, the front page says fill in these formulas. These are the ones you'll get on the exam. So that'll help too. So if you just do that front page of the exam review, it shows you what formulas you're going to get, which I think is everything. I don't think there's anything you could possibly be asking for. The exam review shows you which one you will get on the exam, yes. Hey, as soon as you're done here, take out the exam review and see if I'm right. I believe I'm right, yes. Okay. Graph by solving for x-intercepts and vertex. Okay, if you were asleep most of this and you're like, oh yeah, I remember this, it's okay. You might want to pay attention for this one. This didn't go as well as other questions on the test for this, because there was a lot of steps to it. So let's walk through the steps very carefully. It says graph by solving for x-intercepts. So for x-intercepts, set, well, let me pause for a second and get someone to help me here. We got to think about this. What do we know? There's one little piece of information we know about the x-intercepts. There's something we know what's going to happen. Okay, let me just get my highlighter out for that one. This little factoid is not going to go away. Anytime you're intercepting the x-axis, your y must be 0. That's a huge algebraic help because then this becomes an equation that is just like the ones we were just solving. You're like, oh, that's why we learned to factor. That's why we learned to solve by factoring, was for exactly this situation right here. And so here we go again. We go through the whole checklist. Question 1. Is there a common factor? Yes, there is. What's the common weird? Take that negative. Do you remember? I'm trying to brush the rust off that too. Like, oh yeah, I remember freaking out about this. Take the if there's a negative out there, get it gone. This will be much easier if you take the negative off of that thing. Then I can factor. I'm going to start writing a little smaller here. I need the space here. Two things that multiply to negative 12, but add to 4 are 6 and negative 2. And now I have my x-intercepts. X equals negative 6 or x equals 2. And as I graph these, a whole bunch of stuff is supposed to fall into place at once. See if it does for you. The first thing is, oh, that's why you set y to 0. If they're x-intercepts, their y value will be 0. That's less mysterious now. I highlighted it like you got to memorize it. I think it's highlighted it like, make sure you understand this, that those are the x-intercepts when I set y equal to 0. Then it says find the vertex, and we need somebody who's right on the case to do something pretty easy. It's not too hard what has to happen here, but you have to know to do it. She can't decide. Now they're fighting. I know. I'm really not trying to run a fair classroom. I'm trying to be inclusive. Alina? What? Yes, we'll use the step pattern in a minute. After, yeah, we're going to use the step pattern in a minute. But first, we need to find this vertex. Where is that vertex? How are we going to find it? The middle. Oh, we'll get to the 12 in just a second, too. Yes, the 12 is so important. But the middle, she says. Here, I'm going to do it without the fancy formula. Somebody get the fancy formula. It's not that fancy, but I'm going to do it without it. I'm like, okay, it's somewhere halfway in between here. Right there. Remember this, baby? Axis of symmetry. You don't really need the fancy formula, but it's sure handy, isn't it, to use the formula? Because I had to count in between. I wasn't quite sure. What do I do here to find the x value of the vertex? Yeah, you're just finding the average of those two. Negative 6 plus 2 over 2. And so the x value of this vertex is negative 4 over 2. So the x value of the vertex is negative 2. I know that vertex is along that line somewhere. And it's okay if you're a little confused because we did this a different way in the next chapter. And I'm going to talk about that soon. This was the old way of doing it. I think it has the deeper understanding, though. It's like, oh, I really get what's going on here. Halfway between the x-intercepts is the x value of the vertex. How do I get the y value then, now that I have that x value? Yeah, sub it back into the original, right? Yeah, so sub x equals negative 2 into the y equation. So I get y equals negative 2 squared minus 4 times negative 2 plus 12. And let's just check if the answer surprises you at all. It shouldn't, but maybe you have to look to see why it happens like this. Negative 4 plus 8 is 4 plus 12 is 16. I better type that in to be sure. That surprises me. It doesn't really. But you think about why I might be surprised. Why I might be surprised. Negative, negative 2 squared minus 4 times negative 2 plus 12, 16. Let me put it on there. It's way up here. What does that tell you about the parabola? It opens down. Are we surprised? Sort of. We were sort of surprised because we might have forgotten, oh, that negative out there means open downwards. Now I could use the step pattern to get other points. We didn't actually worry about using the step pattern in that chapter. We just went ahead and went, okay, this is enough. Vertex 2, 0, boom, done. Later we sort of got better at the step pattern. And the step pattern here would be, I'll put it here, step, would be negative 1, negative 3, negative 5. So down 1, down 3 to that y-intercept of 12. So that did come up. That was correct that y-intercept was 12. Then down 5. Then down 7 and off the page, yes? Oops. I skipped a point there. And then I'll try and draw it. It's a little hard on my screen here to get these exactly. Oh, not bad. Not bad for me. And then this final sentence, the blank value of y is blank when x equals what? What are they talking about there? Oh, yeah, there's often this sentence at the end. I don't think I would leave it this vague on your culminated. I'd say, oh, I'd say, oh, I'm looking for the word maximum or minimum here. The maximum value of y is 16 when x is negative 2. Does that all ring a bell? Because that's going back a little bit now. We did it a different way. After that, we completed the square to find the vertex and used the step pattern. So we had another way of doing that. So this might have retreated to the back of your mind a little bit. Questions? This was an all or nothing type question. This went really well for a lot of people on that test. And then other people had it blank and they didn't really know what was happening. And so that's another good one to have ready for on the for the culminating. More time there? See some people flipping. Our first vote will come out. We'll do one more question. Okay? We'll do the complete the square questions, and then we'll see where we're at. Whether we got the endurance for more and have a shorter day tomorrow, or whether it's like, okay, that'll do. You've beat me up pretty good on a Monday, especially those of you who don't have an energy drink with you of some type. Complete the square. Whole different skill, whole different chapter. One of the wildest things you learn in grade 10 right here. Complete the square. Awkward pause. As everyone's brain bounced around. As one of two things happens. Either your brain goes, wait a minute, I remember something about this. Or you're like, wait a minute, I don't remember anything about this. And you're listening carefully. Yes. Completing the square has a magic number. That helps. How do we find the magic number that helps? B. All on one page now, right? Complete the square. You need the magic number. I'll explain the magic. I'll demagicify it. By the time I get done here, I'll be like, this is not all that magical where you got that from. But here it's -3 divided by 2 squared. Ah! It's not a whole number. But what is -3 squared? 9. Not -9, +9. And what's 2 squared? 4. So what do I do with that magic number? Add it and subtract it. You're not allowed to just add it in there. I need that 9/4. But now I can factor this. This thing factors -3/2 all squared. Now over here, I got to do a little fraction work. How am I going to add 2 fractions? What do you need? To add 2 fractions? Common denominator, so I'll put this over 1. And my final answer is here. Now, friends, I would give yourself a mark 1 out of 10. Not what you can do right now. 1 out of 10 is like, oh yeah, I remember this. 10 is like, oh, I remember this perfectly now. 1 is like, we did this in our class? Yeah? If you're a 5 or less, you know what you're doing when I stop teaching here today. You're reviewing complete the square. Because I saw a lot of nods on the other part of it. A lot of people going, yep, yep, yep. So this is where your studying should focus, is completing the square. I'm going to do another one.
Never how I would have done it.
Yeah. Question. What's that? 3/2, yes. Yes, ma'am. I multiply top and bottom by 4 to get a common denominator. And then -9 plus 72 is 63. I did let a lot of people away with decimals here. But I'm still challenging the fraction side of it because I know what's coming in grade 11. So it's worth the practice. Keep trying to nail them down in fractions.
Is that 72/1?
Oh, yeah. Once I got to here, I was looking for 2 things that multiply to 9/4, but added to -3. Here's the hint. If I'm doing the square, it's always half of what was here. That becomes what goes in the brackets. So -3/2 is the number in the brackets. Half of what was here. And where's the hint? I don't know if you remember this part either. We'd go over and highlight that part because that's what was in the brackets later. Yeah. 4.
And 72/4?
Yes. Okay, as bad as that is, that wasn't the worst version of it. The worst version is when there was a coefficient out front. The good news is we just common factor that out. Okay, so that was the extra step there. This actually was done pretty well on the test. Yeah, that people noticed the common factor. So now, it's now ready to complete the square again. What's the magic number? What's the number? Stomp, stomp. What's that from? What am I talking about? Oh, Sesame Street. That's why I don't know any of the new music. Stuck watching Sesame Street all day for 10 years there I was, yeah. B/2 squared? Oh, this one's nicer. 2 divided by 2 is 1. Yes? So I get y equals -4 x squared plus 2x plus 1 minus 1. And what 2 numbers multiply to 1, but add to 2? 1 and 1. Then something weird's going to happen. We need somebody whose memory's coming back on this to explain What the heck happened there? Where did the, perfect question. Where did the 4 come from? I hope I'm going to draw an arrow and a whole bunch of people are going to go, oh, right. X squared plus 2x plus 1 is all in the brackets. And the negative 1 is trying to come back out of the brackets. To do that, I have to multiply it by the negative 4. You were pretty good at this, friends. This wasn't unhappiness when I was marking this. So it's in there. Again, you really want to get negative 4 times the negative 1. And there was still a 3 out there. That's why it ended up at 7. Huh? The negative 1's inside the brackets. If it's going to come out of the brackets, it's got to be multiplied by the negative 4. You say, well, why doesn't this stuff have to be multiplied by negative 4? It is. It's out front of the brackets. The negative 4 is still out front of the brackets there. But that negative 1 isn't part of the brackets. No. Well, you know what you got to do. We were good at this. Pretty good. And so now this is, hey, that's why it's called review, right? Got to go back and go, let's find some complete the square questions in the review, on my test, on the exam review, and go, okay, I'm going to make sure by, you got a couple days, you got till Thursday. So the reason I keep saying you were good at this, I'm not calling you out like, oh, your memory is terrible, we were good at this. No, what I mean was you were good at this. You can become good at this again with a little bit of practice. It shouldn't be that intimidating when you've already done it once. Yes, do we got to review it? Yeah, that's why there's all these days to review. Okay. Good? Good for today. You'll go get some complete the square work done. Because look, here's what I'm going to do tomorrow. Graph using complete the square. Some statement stuff, which I think isn't as bad as what we've been doing. Then you know the 2 word problems, complete the square, complete the square. One has an equation. Remember this? Once it had the equation, we were pretty happy. And then we got one where we got to build the equation. So that's what we got on tap tomorrow. Get some complete the square review done today so tomorrow goes better for you. Your time's your own.